Okay. Good morning, friends. Okay, so last week we did a number talk. Does everyone remember how we did our number talk last week?
With dots.
You forgot. Okay, so a number talk, remember, is a short mental math routine. So we're going to be using our brains and we're going to think without pencil and paper. So whenever I show you these rectangles and squares, I want you to think in multiplicative ways to solve these problems, and you can solve them in different ways. You don't have to think of just one. So remember, if we hold our thumb up, we can say, oh, I remember that in one way, two ways, three ways. So I want you to look at this. I'm going to share my screen with you guys. Okay. Do you guys see this?
Mm-hmm.
Yep.
Okay, so go ahead and think of ways to solve this rectangle full of dots. Taylor, can you go ahead and share your thinking?
Yeah, so I saw a 5 squares across the top,
Okay.
and I saw 3 squares going down. And so I multiplied 5 by 3 and got 15.
Okay. And Renee, do you agree with Taylor's thinking? Or did you
I
saw
do.
it this way?
That's how I saw it.
That's how you saw it. Abby, did you see it this way as well?
Yeah, but when I see the 3 on the side and the 5 on the top, that's how I did it. So I didn't do 5 times 3. I did 3 times 5 in my head.
Okay, so you did 3 times 5. And what does 3 times 5 equal?
15.
15. Okay, so you and Taylor got the same answer, but you saw it in different ways. You saw the 3 first, and then the 5 second. And then if we look back at Taylor's, she did 5 times 3 equals 15, and then 3 times 5 equals 15. So that's the same answer. How is that possible? Taylor, do you know why 3 times 5 and 5 times 3 equals the same thing?
Because 5 times 3 equals 15 and 3 times 5 equals 15?
That's good. Okay, so it doesn't matter where the 3 or the 5 is. They both equal the same thing. That's really good. Okay, so let's look at our next rectangle. Okay, go ahead and put a thumb up to your chest whenever you figure out how many are on here. Okay, Abby?
I saw 2 on one side and 5 on the top, and so I did 2 times 5, and that's 10.
Okay, you said you saw 2 on the side. What would this be called?
A row.
So you saw 2 rows. And then what would this be called?
The columns.
Okay, so there's 5 columns. Good job. And you said it's 2 times 5?
Mm-hmm.
Ooh. And what
And
is
it's
2?
10.
10. Okay, so I have a question for you guys. What if I were to move this and we see new squares? What can we do?
You can add them on to the 10.
Okay, so can anyone tell me what this blue square is? Put a thumb up to your chest when you know. Renee, can you tell me what this blue square is?
There's 4.
Okay, and how did you know this is 4?
Well, I see 2 columns of 2.
Okay, good job. And then what? Oh, 2 columns of 2. Okay. So 2 by 2 equals 4. Taylor, do you agree with Renee that 2 times 2 is 4?
Yes, I agree. I didn't do that. I just saw 4, but yeah, 2 times 2 is 4.
Okay. So, Abby, looking at this and then looking at a fresh one with no one's writing on it, how many do you see?
7 on the top and 2 on the side.
Okay. And how did you know that? Did you add from the last time or did you just know?
I added from the last time.
Okay.
I knew, so I saw 5 and then I said 6, 7.
5, 6, 7. Okay, that's good. 5, 6, 7. And then what is 7 and 2? Taylor?
9.
9?
Oh, we're multiplying? Oh. 14.
14. Okay. So, did everyone see how we can add on to our problems? And see, it could have been difficult if we just would have saw that at first. Right? That's kind of big. Does anyone know what we just did?
We added.
Okay. What did we do whenever we solved the 2 times 5 equals 10 and then we saw 2 times 2 equals 4 and added those together? Can anyone think of the word that we did?
Well, we counted up for 1. We counted up from 5 to 7.
Okay,
But-
yeah. We added on from 5 to 7 and we added on 2 more over here. Good job.
Yeah. And then you could take the 10 and add just 4.
Yeah. So
Yeah.
10 plus
That's
4.
what I did too.
Mm-hmm.
Cool. So we're seeing different ways that we can add on to frames. Cool. Okay, so I'm going to give you some time to do this one because this one is kind of big. So if you need to, you can cover up the blue with your hand and solve it that way. Or if you can solve it by looking at it, then go ahead. I'm going to put your thumbs up when you're ready. Taylor, can you tell me how you solve this problem?
Yeah, so I just, I didn't have to cover up the blue. I just did all of them together.
Okay.
So on the top row, there's 1, 2, 3, 4, 5, 6, 7, 8.
Okay.
And then there's 3 columns. And I didn't know what 8 times 3 was, but I did know that 8 times 2 was 16. And then I have to add another 8. And I know that 4 and 4 makes 8. 4 plus 16 is 20. And then 4 more is 24.
Okay. So, Renee, did you solve this the same way as Taylor did, or did you see it differently?
Well, I just knew that 8 times 3 was 24.
Okay, so you used your known facts. That's good. Abby, did you solve this the same way as Renee, or did you solve it similar to Taylor?
I did it similar to Renee.
To Renee? Okay, so you just knew that 8 times 3 was 24.
Yeah.
Oh.
And I actually did 3 times 8 because I read from the left to the right.
Okay, so
In my
you
mind.
3 times 8.
Yeah.
And Renee did 8 times 3. And is that the same thing?
Yes.
24?
Mhm.
And do you guys remember what this property would be called when we have 2 factors that are flipped, but we have the same product?
Commutative property.
Commutative property. Great job, Taylor. Okay, so what if I were to flip this? What do you guys think about that?
If you were to break up the whole thing into the group of the blue and the yellow,
Mm-hmm.
even if it's flipped, you would still have the same size group of blue and the same size group of yellow.
Good. So it's all the
Okay.
same. So this is 5 and this is 3. And we could solve it the same way. 5 plus 3 is 8. Right? Okay. So I want you guys to think about the next dot card and let me know with the thumbs up what you got. Renee, can you tell me what you got?
Well, I noticed there were 5 columns and there were 4 rows. And I just counted by fives 4 times. 5, 10,
Use your
15,
fives.
20. And so I think there's 20.
Okay, so what you're saying is you said there were 4 columns, or I'm sorry, 4 rows, and you said 5, 10, 15, 20.
Mhm.
Okay. Taylor, do you think that you could repeat what Renee did in your own words?
She saw 4 rows
Mm-hmm.
and 5 columns,
Mm-hmm.
and she multiplied that to get 20.
Renee, is that right?
Yeah. I counted by fives.
Okay, Taylor. So Renee counted by 5. She didn't multiply. Fine.
Okay.
Does that make sense to you, or would that make sense to count by fives?
Yeah, if you wanted to, but I was thinking of multiplication.
Okay, and that's fine too. It can be solved either way. So let's think. What if we added on to that? Let's think about that one. Remember to put a thumbs up. Taylor, how did you solve this?
I saw 7 on the top row. And 4 columns.
Okay, so you just said you saw 4 columns.
Or rows.
Rows. Okay, great.
Mm-hmm. And I know that 7 times 2 is 14. So if you double that, it's 28.
Yes. So you said double, so double means 2, right? 28. Abby, do you agree with Taylor's thinking?
Yeah, I do agree, but I saw it another way too.
Okay, how did you see it?
I saw, I saw 7 on one side and 4 on the other, but I didn't know 7 times 4. So I did 7 times 3 and I got 21 and I just counted up to a 7 more time. I counted up 7 again.
So y'all both did it really similar and you just added on. So you added on 7 and Taylor multiplied 2 more from 14 to get 28 and y'all both got the same thing. So that's pretty cool that you can use different strategies and get the same answer. Renee, can you add anything to Taylor or Abby's thinking or strategy? Or did you solve it similar?
Well, I kind of did it a little bit different because
You did.
I knew that in the yellow there was 20 because I discovered that 4 times 5, the 4 rows and 5 columns was 20, and then I knew that there were 2 more columns added to the 4 rows,
Mm-hmm.
which was 8. And so then I said 20 plus 8.
Great. That's awesome. So you used how we did last time. We knew that there was 20. And if you noticed, we added the blue. So we added on 8 to the yellow. And then another way that we could do this is, so you see how we have the blue covered in this problem? We're kind of decomposing, and decomposing is when you take a big number and make it smaller to solve. Isn't that neat? Okay. Here's one of our last problems, one of our last blocks. So I'm going to give you some time to think about this one because this one's just pretty large. Okay, so I see Abby and Taylor both have their thumbs up. Before you guys tell me what you think the answer is, I want you to discuss with each other both of the strategies that you used. So talk with your partner and talk with each other about what strategy you used.
Abby, what strategy did you use?
I did 7 times 5 equals 35 because I saw automatically those 5 at the top and I just added 2 more on. And then there was 5 rows, so 7 times 5.
Well, it was really big, so I broke it up into the group of yellow and the group of blue. So I saw 5 rows and 5 columns, so I know that was 25. And then I saw 2 groups of 5, which I knew was 10, so I just added 25 and 10.
Cool.
Renee, after hearing Abby's and Taylor's strategies, did your strategy change, or did you think of another way to do it, or did you stay the same?
I stayed the same. It was the same as Taylor's.
Okay, and can you repeat that for me so I can write it down?
It was in the yellow.
Okay.
It was 5 columns and 5 rows, and that multiplied is 25. And
Okay.
then in the blue there were 2 columns of 5, and that was 10. And then I said 25 plus 10
Okay.
was 35.
And 25 plus 10 is 35, I heard you say. About 10. Okay, so that's pretty cool that you guys both broke up the yellow and the blue. So you decomposed and you said that there's 25 yellow blocks and then there's 10 blue boxes. And I think that that's easier to solve for me, but for other people, they might just look at it and say, I know that 7 times 5 is 35. And that's similar to what Abby did. Okay, guys, that was the last one. So I'm going to stop sharing my screen. And today we saw that there were many different ways that we could break down rectangles and solve them. We can decompose and we can add on, and you guys did a great way. You did great strategies of doing these. Okay, so I'm proud of the work that you did today.